So the problem statement is like that. Please listen, I'll be also writing it, but let me first explain with the help of examples. Okay, so you have been given an array list or array of integer. Okay, your task is to find the second largest element present in that array. So for example, let's see, this is the array. Okay, they not necessarily in a sorted order. Okay, array need not be in a sorted order. So let me just take any value randomly like this. Okay, so this array, if you see, it contains only positive integer. It can also contains the negative integer as well. Okay, and zero as well. What I have to find out is, if you see, the largest element is this one. Okay, and the second largest element is this one. This will be my answer. Okay, in this array. Okay, so this one, this is the example 2. Let me take the example 2. Okay, so let's say if the input array is like this. Okay, sorry, yeah, if the input array is like this, so in this in array, if you see, the largest element is 10 and there is no element which is second largest. Okay, so in this case you can return anything, like you can return second largest element does not exist in the array. Okay, or simply you can return the -1 also. Okay, that is also fine. And another thing, this integer can be negative as well. So they can be -1, -3, -27. Okay, and -10, let's say. Okay, let me take this one only. So here the largest element, if you see, then that is nothing but -1, and the second largest element is what? -3. Okay, so you'll have to return this one. So that is the scenario. This will be the answer. Okay, so you'll have to write an algorithm for this. Okay, and I'll also be later on pasting the link for the problem to code. Okay, be it a Coding Ninja or LeetCode, wherever you can easily find this question. Okay, so we are supposed to write an algorithm for this problem. So what we can do over here, so 2-3 approaches you can use. Okay, the first approach is very simple. You can simply use the merge sort. Okay, simply apply the merge sort and sort this array with the time complexity of n log n, and then you can return you will just go to the last index. Okay, here in sorted array. So let me explain what I want to say. Okay, so first I'll sort the array. Step 1, approach 1 I'm explaining. Okay, so sort this array. Now 3, 5, 6, 9, 10 and 102, and what I can return, simply, if you see, this is my second largest element, right? Okay, so what I can do, I can sort the array and return this element. Okay, clearly, so you will get the second largest array. But the problem is, what if the array contains all the duplicate element like this? So what I can do in this case, I'll simply check this 2 element, because after sorting the array, this must be the this position must be the position of the second largest element. Okay, if array does not contain the, what I can say, repeating value. Okay, or the repeating value of the largest element, you can say. So this must be the position of the second largest element. Okay, so this is the case. Okay, this is the case. If you see, if you will sort this array, this is the case. If you will sort this array, this is the second largest position. But what if the largest element is repeating? Let's say here in this example, okay, in this example, the array elements are like 9, 6, 3, 5, okay, 102 and 102. This is the array element, right? Now let me sort this again. So if I'll sort this, what I will get is this one. This is what I'll get. Okay, now if I'll directly go here and check what I'll check this time, if I'll directly go here and return, the answer will be like, no, I'll get the wrong answer, right? Because I'll be getting 102, right? That is not the answer. Clearly here the answer is 9. This is the answer. So what I can do, if I'll go by the first method, that is nothing but sorting the array, what I can do is I can go to the last index, okay, and I can compare this last index with the second last index, and this I'll have to do it recursively, okay. And whenever these two are like equal, if you see this is 102 and this is 102, I can move left by one position here and again compare these two, okay. Now if I'll compare these two, now these two are not equal, right? So I can return this one, okay. And in this case, if you see, if all the array elements are like this, so what will I do? I'll go here and I'll compare these two, okay. These two are same, I'll come here and I'll compare these two now. These two are same, I'll come here and I'll compare these two now. These two are also same, okay. So I have arrived to the end of the array, okay. So in this scenario I can simply return -1 because the second largest does not exist. So this is the approach, okay. So I'll be coding this approach in Java, but if you see, I code in Java, so I'll be coding in Java. You can also do the coding part in C++. But if you'll see, in this approach I'll have every time, okay, every time, what will be the time complexity? Let's dig into that. So step 1 was sorting the array, right? Sorting the array, okay. And step 2 is traversing the array. What will be the time complexity for this? Average, let's say we are taking the average case time complexity, so it will be n log n. Let's say that I'm using the merge sort, okay. And in this case, what will be the time complexity? Order of n. So overall time complexity, or I should say asymptotic time complexity of this approach will be order of n plus order of n log n. Clearly this factor is bigger, the order of n log n. But what if I say I can further optimize this approach, okay. I can further optimize this approach, okay. Yeah, so how to optimize this approach is, in a linear time also I can do this. If you see, this is greater than linear time, right? So order of n solution also exists for this one, okay. Simply what I can do is I can traverse the array in one go and I can find out the second largest element. So that solution I'll be uploading in the next video, and later on we'll code this problem, okay. So I'll be again explaining the problem in the next video, okay. Thank you so much.